Hi guys, Miss Berg again. We're going to be going over your chapter 6 um, chapter review. So this is at the end of the book. So you can go to the back, which is 413. So you can go to page 413 and you can start with me. I am going to be skipping around. There's going to be some that I'm not even going to do. So just do the work with me and follow along. All right, I am going to turn it around. The first one that I'm going to go over is actually going to be number 2. So it says, Rodrigo practiced playing the guitar with 15 1/3 hours over the past 3 weeks. He practiced 6 1/4 hours on the first week and 4 2/3 the second week. How much time did Rodrigo spend practicing on the third week? Use the numbers and symbols to write an equation to represent the problem. Then solve the equation. So here it is. We are going to first make an equation and then we're going to solve it. So the first thing is there's several things that you could do here. The first thing that you could do is you could say, okay, so he did this for a total of 3 weeks and it was 15 1/3 hours. So that would be where that 15 1/3 goes. Then he practiced 1 week was 6 1/4 plus he did the second week he did 4 2/3 and then his third week is unknown. So that is where your X is. So they want to know how to figure this out. Well, first thing that you should do is you should add up these first. Then once you find these, then you can subtract it from here. So really what I'm going to do is I'm actually going to turn this around and do a subtraction problem. All right, now, do you see how there are different denominators? I'm just going to change all the denominators right now. So if I use my bigger of the 2, which is 4, and I keep going by 4s until a 3 can go into it. So a 3 cannot go into 4. Next multiple of 4 is 8. Can I get a 3 to an 8? No, I cannot. So the next multiple of 4 is 12. Can I get a 3 to a 12? And that is where I can. So I'm going to change all of these to 12s. So what do I do to a 3 to get it to 12? Times it by 4 and this one by 4. So this one would be 15 4/12 minus, and then over here, what do I do to a 4 to get it to 12? I times it by 3 and this one by 3. That would be 3/12 and then 6 wholes. Plus here, what would I do to a 3 to get it to 12? I times it by 4 and times this one by 4, and that would be 8/12. So 4 wholes. So I'm going to add these first. So 8 plus 3 I can now add because my denominators are the same. That would have been 11/12. And now I can look at my whole numbers, which is 6 and 4, which is 10. But am I done? No, because now I have to subtract it from 15 4/12. So I'm going to do that up and down here, 15 4/12 minus my 10 11/12. Okay, so remember this is what I have out for my customer, and this is what they come in wanting. So I have 4 slices of pizza ready to go, but they want 11. Can I give them fulfill their entire order that they want? And the answer should be no, we can't. So we have to go to the back. I'm going to take a pizza. So now there's only 14 back there in the back. I'm going to make up my pizza and I'm going to make them happy by cutting it up how they want it, which is in 12ths. So a brand new whole pizza with 12ths would be 12 out of 12 slices. But we don't just have 12 out for them. We have those 4 from when they first walked in. So that is actually a total of 16 now. So now can I give them 11? And the answer is yes, I can. So what is 16 minus 11? It is 5/12. And then 14 minus 10 is 4. So my answer would be 4 and 5/12 left. Okay, next. My next thing that I'm going to be doing is going to number 4. So, I do want to look at this one real fast here. So I know we haven't really talked about this, but I do want to quickly go over this. So it's saying what is round this to the closest benchmark. So Liam bought 5 7/8 pounds of steak, and he used 2 1/16 pounds of steak for the cookout. So they want you to round the closest benchmark of what he bought of steak. So he bought 5 7/8. All right, so they're saying the closest benchmark. What that means is they want you to find like 5 is between 5 7/8 is between 5 and 6 pounds. So the half point would be 5 1/2. All right, so what they want to know is what is 5 7/8 truly closest to? Well, if we were to change this to eighths, 5 is just 5 0/8. And 5 1/2, when it comes to eighths, is actually timesing it by 4 and this one by 4. So that would be 5 4/8. And then 6 wholes when it comes to eighths. This is where it gets a little weird looking. You're actually going to have to change this to 8/8 by making up one of those pizzas. So the other way of saying this is 6 wholes is also saying 5 8/8. So they want to know what is 5 7/8 closest to. Well, 7 slices, which one is closest to 7 slices? A 0, a 4, or an 8? In this case, it is closer to that 8. So therefore, it is close to your 6 pounds. And then it says, so that is what they're trying to do on here. So this is the same thing. What did he use about the steak? So he used 2 1/16. So 2 1/16 pounds is between 2 whole pounds and 3 whole pounds. And then, of course, your middle of the road would be 2 1/2. So if you were to change these to 16ths, 2 wholes would just be 2 0/16. This one, if I'm changing this to 16ths, I would times it by 8 and this by 8. So that would be 2 8/16 is closest to 2 1/2. And then when it comes to 3 pounds, when it comes to 16ths, you would have to do 16 over 16 would be 1 whole. And then what would be left would be 2. So 2 plus 1 whole is your 3. So what would be 2 and 1 out of 16? What is that 1 closest to? Is it closest to 16, 8, or 0? It is closest to that 0, which means it is close to just 2 pounds. So it's saying about what would be left over if he used about 2 pounds and he bought 6 pounds worth. It would be about 4 pounds remaining because you would have to subtract those two. So that is truly what's going on there, but I'm not a big fan of estimation when it comes to fractions, but I do want to show you it because eventually you will be getting to it with number sentence, number lines up in the 6th grade, but you're really not going to be seeing it much this year. All right, so here Jackson picked apples for his family. He picked a total of 6.5 pounds. He took 2 3/4 pounds to his aunt and 1 5/8 pounds to his mother. How many pounds of apples were left to give to his grandma? Use the numbers and symbols written to represent the problem and then solve the equation. So again, we're going to do exactly like we did on number 2. So it says he picked a total of 6.5 pounds. So this is what the total is. 6.5 pounds is what it was. Then it said he took 2 2/3, 2 3/4 to his aunts, and then plus he gave 1 5/8 to his mom, and then plus an X. We don't know how much he gave to his grandma. So in order to figure out what X is, first thing that I would do is I would add up these. Then whenever you find out what that is, then you subtract it from 6.5. So what you should do first is find a common denominator, which we can change everything to eighths. So this would be 6/8 and 2 6/8 plus 1 5/8. And then also while I'm at it, I could just change this to eighths too. So if I did that, times it by 4 and by 4, that would be 4/8, so 6 4/8. So if you added this, that would be 11/8 and then 3 wholes. So how many eights go into 11? That would be 1 with 3, so that would be 3 wholes plus 1 3/8. Comes out to be a total of 4 3/8. So now that we have that, now we would have to subtract it from 6.5, which is really when we change it into eighths, would be 6 4/8. Then we can subtract off the 4 3/8 that we just found. So now I can subtract. Can I have 4 and take away 3? Yes, that would be 1/8. And then what is 6 minus 4 is 2. So the answer would have been 2 1/8 pounds. All right, this one just says write 2/5 and 1/3 as equivalent fractions using the same denominator. So we have to come up with a common denominator. You guys could always use that quick way as well, which is just taking those two denominators here and multiplying it, and it would have been 15. So we could have changed these to 15ths. So what would I do to a 5 to get it to 15? Times it by 3 and this by 3. That would have been 6/15. So that would have been one fraction right here. And then here, what would I do to a 3 to get it to 15? I times it by 5 and this one by 5. So this one would be 5/15. So those were your two fractions. All right, next it says Jill bought 2 1/3 boxes of carrot muffins for a bake sale. Mike brought 1 3/4 boxes of apple muffins. What is the total number of boxes of muffins that both Jill and Mike brought into the bake sale? So this is what Jill brought, this is what Mike, and they want to know the total amount of muffins that came in. So when I'm doing that, the total number, I need to add these. So 2 1/3 plus 1 3/4. All right, first thing I need to do is come up with a common denominator. You could just do that quick way of timesing them, and you would be changing them to 12ths. So times 4 and times 4, that would be 4/12. So 2 4/12. And then here, what would I do to a 4 to get it to 12? Times it by 3 and this by 3. That would be 9/12. So now you can add. What is 4 plus 9? That is 13/12. And then 2 plus 1 is 3. The issue is we have an improper fraction. So remember, you should have separated these. So that's really saying 3 wholes. Now we have to figure out what 13 twelfths is. So 12 can go into 13 one time. Subtract, that would be 1. So actually my mixed number here is 1 and then 1 12th. 1 12th. So when I do this, I should add these. That would be 4 and 1 12th would have been your answer. And that is your total answer is 4 and 1 12th. The next thing that I am going to go over is just part B of this, just part B. So it just says the fractions 3/5 and 6/10 are equivalent to each other. So let's see if this is true. They want to know whether 3/5 and 6/10 are actually equivalent to each other. Equivalent means, are they equal to each other? So the question is, are they equal to each other? Well, in order to find out whether they are equal, we need to come up with a common denominator. So looking at your bigger one, which is 10, can I get a 5 up to a 10? I could. So I'm going to just change these to tenths because it's just less work. So this would become still remain the same because it's already in tenths. What would I need to do to a 5 to get it to 10? I times it by 2 and this by 2. So 2 times 3 is 6. So is 6/10 equal to 6/10? Yes, it is. It sure is. So are the fractions 2/5 and 6/10, are they equivalent? Is that a true or a false statement? It is a true statement. They are equivalent to each other. Equivalent meaning the same, equal. All right, I'm actually going to skip a whole bunch here. I'm going to skip the rest of this page and the rest of this. We are actually going to go right on over here. So it says Elena bought 3/8 pounds of Swiss cheese and 1/4 pound of American cheese. Which pairs of fractions are equivalent to the amounts that Elena bought? Mark all that apply. So remember, it says 3/8 and this one was 1/4. And we need to change these both to 64. So to do that, to see if they come out to be the same, what do you get an 8? What do you have to do to an 8 to get it to 64? You have to times it by 8 and you do the same to the top. So when you do that, that would actually be 24 over 64. So yes, this one is equivalent. Now, how do I get a 4 to a 64? Well, in order to do that, since I don't know it off the top of my head, I should actually divide this out to figure out how many 4s go into 64. So 4 can go into 6 one time. That'd be 2. Check it. We are good. Bring down your 4. How many 4s go into 24? That is 6. 6 times 4 is 24 with nothing remaining. So therefore, we would have times it by 16 and this by 16 to get to 64. So it's 16 times 1, 8. And this is where it is not going to work. So therefore, this is not a true statement because of this one right here. Now, it says, now let's change it to 16ths to see if this is true. All right, so now we're going to take these same fractions and change them to 16ths. So how do I change an 8 to a 16? I times it by 2 and this one by 2. So 3 times 2, is that 6? Yes, it is 6/16. What do I do to a 4 to get it to 16? I times it by 4 and this one by 4. 4 times 1 is 4/16, and this is true. So therefore, B is correct. They are equivalent fractions. Again, still using those same fractions that they had up here. Remember, it was 1/4 and 3/8. So how do I get a 4 to a 32? I times it by 8 and 8. So then that would be 8 over 32, and then timesing this by 4 and by 4, that would have been 12 over 32. So the 12 over 32 is correct. However, this is not, because it should have been 8 over 32. And then the last one, again, using the same fractions of 3/8 and 1/4, and we're going to change them to 40ths. What do you do to an 8 to get it to 40? Times it by 5, and this one by 5. 5 times 3 is 15, so 15/40ths does work. Now, how do I get a 4 to a 40? I times it by 10, and this one by 10. So 10 times 1 is 10/40ths as well. So therefore, these are equivalent. So there was actually, the answers were B and D for this one. All right, next, it says that the 4 students spent volunteering last week. The table shows how much time each student spent volunteering. They want you to match each pair of students with the difference between how much time they spent volunteering. So the difference between the two means answer to a subtraction problem. So we're actually subtracting here. So Amy was 4 and 5/6, and Victor was 5 and 3/4. So we need to subtract the two. Since Victor is bigger, I'm going to put Victor first, and then Amy's on the bottom, and then I'm going to subtract the two. First of all, I need to come up with a common denominator. I could have changed these all to 24ths, or even 12ths. It really doesn't matter. All of these could have been changed to 12ths actually. So I'm just going to just keep it easy and simple and just change everything to 12ths. So what do I do to a 4 to get it to 12? Times it by 3, and this one by 3. This one would be 9/12. So that would be 5 and 9/12. What do I do here to get it to 12? Times it by 2, and this by 2. So that would be 10/12. So this would be 4 and 10/12. All right, so I have 9 slices and I need to get rid of 10. Can I do that? No, I only have 9 slices and my customer wants 10. I don't have enough for them. So I'm going to go into the back. I'm going to make a pizza. Here it is. I'm going to cut it up how they like it, which is in 12ths. So a whole pizza, when it cut up into 12ths, is 12/12. Plus that 9 that was already sitting out comes out to be 21 slices. So now can I give away 10? And the answer is yes. So 21 minus 10 is actually 11 over 12. And then looking at the whole numbers, 4 minus 4 is nothing. So when you subtract these out, the difference comes to 11/12. Next, Cal and Beth. So Cal is 5 and 2/3. And Beth is 6.5. So since Beth is bigger, I'm going to change that one. Minus 5 and 2/3. All right, now this one, I could have changed it all to 12ths, but then I could have also have looked and saw, oh, I can just multiply these two as well. So I'm going to actually do that one. I'm going to change everything to 6. So I'm going to times this one by 3 and this one by 3. So that would be 3/6. So 6 and 3/6. This would be still 5 wholes, timesing this by 2 and this by 2. That would be 4/6. So now I can subtract. So I have 3 slices out for my customer, but my customer comes in and wants 4. Do I have enough to give them? And the answer should be no. So we need to go over and borrow a pizza. I made the pizza in the back. I'm going to cut it up how they like it, which is in 6. So a whole pizza, when it comes to 6, would be 6/6 plus the 3 that were already out, comes out to be a total of 9/6. Now can I give away 4? Yes, I can. So 9 minus 4 is 5/6. So your answer is 5/6. So then what is left would actually be going there. All right. You can go ahead and try this one on your own. What they're asking is whether they come out and need renaming. Renaming means going and borrowing and renaming it. So they want to know whether these subtraction problems will need renaming or not. If it does need renaming, put it in here. If it does not, you can put it over here. So, and then it says that they want you to find the difference too. Which is finding the answer to the subtraction problem as well. So please put this on pause and try this one on your own. Okay, so if you did go and rename them and see what it came out to be, if you did that, this one, you would have to go ahead and rename it, which I did up here. Because once you change it to 12ths, it would have been 4/12 minus 9/12, which cannot happen. So you had to come over and borrow, just like we were doing. And when you did, it would come out to be 7/12. So this one actually required renaming. The next one also required renaming. 1 3/4 minus 7/8. Because if you change them to eighths, this one would have been 6/8 minus 7/8, which you cannot do. So you had to come over and borrow and rename it to 8/8 plus 6 more would be 14/8 minus 7/8 would be 7/8 remaining. So actually that one required renaming. The next one, which was your 5 2/3, is right here. So if you did that and you changed everything to 24ths, it would have been 16/24 minus 15/24. You can do that. So therefore, it would have been 1/24 and then 3 wholes. So therefore, that did not require renaming. So that was the only one that was over there. And then the last one, if you did it, you should have changed it all to 15ths. So when you do that, it would have been 3/15 minus 5/15. And you cannot do that. So you had to actually rename. And if you renamed properly, it would have been 3 13/15. All right. So that is that part. And then on the last page, we are going to do these together. So it says Mr. Clements paints his barn for 3 3/5 hours in the morning. He painted the barn for 5 3/4 in the afternoon. They want to know whether this is true or false for each statement. A common denominator of the mixed numbers is 20. So we could do this real quick. 3 3/5. They want to know how much did he paint altogether. So to do that, we would have to add this. But in order to add, we first need a common denominator. So we could do the quick way of just multiplying these two, which would be 5 times 4. So what is 5 times 4? That is 20. So a common denominator of the mixed numbers is 20. Is that a true or false statement? This is actually a true statement. You could have changed all of these to 20ths. So that is true. The amount of time spent painting in the morning can be rewritten as 3 15/20. All right, so this one, is this a true or false statement? So in order to change this to 20ths, just the morning, because it said just the morning, so that's the top number. How do I get a 5 to a 20? I times it by 4 and this one by 4. So that would be 12/20. So 3 12/20. And what did they say? They said it should have been 3 15/20. So therefore, is that a true statement? Well, no, it is not. So this is actually a false statement. That does not work out. Then it says Mr. Clements spent 2 3/20 hours longer painting for the afternoon than the morning. Oh, so this is actually spent longer. So they want to know how much longer he spent in the afternoon than in the morning. So actually, this is not an adding problem. This is actually subtraction. So they kind of tricked me here. we have to subtract the 2 to figure out what is the answer. So when I rename this, I already did that up here. It was 3 and 12/20. Then I need to rename this one by changing it to 20ths. So that would be 15/20 and 5. So can I subtract 15 minus 12? Yes, I can. That would be 3/20. And then my whole number would be 2. So 2 and 3/20 is the answer. So this is a true statement. All right, next it says Tom exercised 4/5 of an hour on Monday and 5/6 of an hour on Tuesday. And they want you to complete the calculations below to write equivalent fractions of the common denominator. So they wanted you to come up with a common denominator. The quick way to do this, of course, is to take the 2 denominators and multiply them. So 6 times 5 is 30. So what we could have done is we could have changed these to 30ths and this fraction to 30ths. So how would you do that? You should have done 5 times what will equal your 6. It is 30, sorry. 5 times what will give you your 30. You should have times it by 6 was missing. So 6's need to be multiplied up here to make it even. 6 times 4 is 24. And then here, what do I do to a 6 to get it to 30? I need to times it by 5 and this one by 5. 5 times 5 is 25/30. So here are my new fractions when I did that. So how much time did Tom spend exercising on Monday and Tuesday combined? So they actually want to know the combined amount. So when we are combining to see how much total he spent exercising, we actually should be adding these numbers together. So when you do that, 25 plus 29, if you need to do it up and down for you to see it better, you may certainly do that. That would be 49/30. Okay, so 30 can go into 49 one time, and that would be 19 remaining. So my answer would have been 1 and 19/30 of an hour. How much longer did Tom spend exercising on Tuesday than he spent on Monday? So which one was Tuesday? It was the 5/6. So that was 25/30. They want to know how much more he spent on Tuesday than on Monday. So in order to figure out that, you would have to find the difference of those two. So that means you would have to subtract, which would be 1/30 of an hour. And that is the end of the review for chapter 6. All right, we will pause, we will stop this, and then the next chapter will be chapter 7. So we may have a quiz or a test on chapter 6, but for right now, I'm just going to have you just watch the review. All right, I will see you guys next time. Bye.